All right, here's the solution to the diving board problem. First thing is to draw all the forces acting on the diving board. So let's start with that. The forces will be the weight of this person downward, the weight of the board. The weight of this person is going to be just about 600 newtons. The weight of the board itself is 2 kilograms, is just about 20 newtons. There'll be a force up from this pivot point. We can call it the force of the fulcrum or the force of the pivot. We'll call it the force of the pivot. And the bolt is going to provide a force this way, the force of the bolt. Those are the 4 forces acting on the diving board. Remember, the diving board does produce a normal force on the man, but that's not part of this problem. That's not a force acting on the diving board. Determine the force of the bolt on the board. We need to figure out that force there. Determine the force of the fulcrum, or the pivot. No, maybe I should call that the force of the fulcrum. We can call it the force of the fulcrum. Force fulcrum. And determine the center of mass of the diving board student system. All right, so first things, as always, sum of the forces. All these forces are in the y direction, equals ma, which is 0. The whole thing is in equilibrium, right? So everything equals 0. Sum of the forces, force of the bolt, which is negative, plus the force of the fulcrum, minus the weight of the diving board, minus the weight of the guy or the student or whoever this is. All of that equals 0. So we get the force of the bolt and the force of the fulcrum combined equals 620 newtons. Right? You can bring those to the other side of the 0, they become positive. So what do we want to know? We want to know the force of the bolt. First one, we know the force of the bolt. The force of the bolt would be equal to the force of the fulcrum minus 620. Two unknowns. We can't solve this way. Looks like we have to go to sum of the torques. Sum of the torques, maybe we can solve something out there. Sum of the torques equals also in equilibrium, 0. So the sum of the torques is going to be the torque from the first force plus the torque of the second force plus the torque of the third force plus the torque of the fourth force, all equals 0. We can assign these things numbers. We can make this be force 1, this can be force 2, this can be force 3, this can be force 4. Right, and one of them we're going to choose to be our reference point, our spot that we compare everything else to. So I don't know, it can be it would make sense for it to be either the bolt or the fulcrum. You could do it either way. I'm going to make it the fulcrum. So this is going to be the force of the bolt times 1 meter. And that is going to produce a rotation of the diving board in this direction, which would be counterclockwise. So that's positive. I'm going to say the next one, torque 2, is the force of the fulcrum. How far away is that from our reference point? That's 0 meters away. So that's going to vanish. If this is our reference point, right, that was 1 meter away. So that was it. This is now, force 2 is now 0 meters away from our reference point. Force 3 is going to be 20 newtons. times also 1 meter away. All right, the whole board is 4 meters. And so the middle of the board is 2 meters away. So 1 meter further. And that, the weight of the board is going to make it swing this way, which is clockwise. So that's negative. So we have to make that negative. And likewise, the weight of the guy is going to cause a clockwise rotation, or the student here. So the force 4 is going to be negative 600 newtons times its distance away. Again, the whole thing is 4 meters long. This is 1 meter over. So to the end would be 3 meters, but he's not standing at the end, standing a half meter in. So this is 2.5 meters. All of that equals 0. Okay, so we get force of the bolt times 1 meter plus 0 minus 20 Newton meters. That was supposed to be newtons. I don't know why I wrote an M there. Minus 600 times 2.5 is, was it 1,500? 600 times 2.5 is 1,500. Yep. Minus 1,500 Newton meters. All that equals 0. So combine like terms, we get the force of the bolt times 1 meter minus 1,520 Newton meters equals 0. Well, we just figured out the force of the bolt. The force of the bolt times 1 meter equals 1,520 Newton meters. Divide both sides by 1 meter. We would get the force of the bolt to be equal to 1,520 newtons. We got the force of the bolt. 20 newtons. Now the force of the fulcrum. Okay. So back here, 1,520 newtons equals the force of the fulcrum minus 620 newtons. So the force of the fulcrum equals, add 620, 1,520 plus 620 is 2,140. 2,140 newtons. That's the force of the fulcrum. 2,140 newtons. Okay. The center of mass. I'm going to pause this for a second and do that as a separate recording. Center of mass.